Hey traveler, come on in and welcome to the GameDev Tavern, a tiny little spot on the internet where we build fun games together. My name is Nicholas and this is episode 14 of the tutorial series where we create a pixel art beat-em-up game in Godot. And welcome back. In today's episode, we will continue to spend time polishing our stage. So if you played through last week's episode, you probably noticed something odd with the camera when we complete a checkpoint. So I'm going to go ahead and show this to you right now. Go ahead and get rid of all of these people. I'm going to go to the side of the screen. There we go. So you probably saw this. As soon as a checkpoint is completed, the camera just teleports back to the player instantly, and it creates some annoying motion that we'll want to get rid of. So the reason for this is because in the world scene, we move the camera's position to the player's position as soon as the camera is unlocked. And ideally, we want the position to gradually move towards the player's position rather than move there instantly. So luckily for us, Godot's camera node actually has a built-in property called position smoothing that we can enable. And we'll set this to 3 pixels for now. And this will allow the position of the camera to gradually move towards the desired position. So let's go ahead and try this out. I'm going to go ahead and kill those enemies. I'm seeing some odd behavior from the enemies. As soon as they drop the knife, they instantly try to pick it back up right away after they're hurt. Maybe we'll tweak this right after. So here you can see that the camera just smoothly scrolled towards the player, and it now prevents this jerky motion. So that's going to be a lot better. So let's go ahead and fix this odd behavior for enemies that are using weapons. So right now, they will attempt to pick up the weapon on the floor as soon as they drop it, which prevents them from actually engaging with the player. So let's hop over into the character and we'll go over into the script. And here you can see on the onReceive damage method that there is a timestamp that we set whenever we drop the knife. At the same time, characters also contain a property called duration between knife respawn, which we can probably use to make sure that the enough time has been spent before a weapon can be picked back up. So now let's hop over into the can pick up collectible. And here what we'll do is we'll just check if enough time has been spent. So if the current time minus the timestamp since we lost the weapon, so if we haven't spent enough time, we'll just return false, meaning that we can't collect the collectible. Okay, let's try this out and make sure that the enemies now engage with the player rather than try to spend their time picking the knife back on the ground. Okay, you can see now that they are actually trying to engage right away. Okay, so next up, we'll go ahead and set up our barrel containers. And so similar to our enemies, these containers will need to be placed somewhere within our stage scene here, but we'll actually want them to also be teleported back under the actor's container so that they can be properly wire sorted. Now, we could implement that system exactly the same way that we implemented enemies, meaning that they would get destroyed when the stage is ready, and then we would go ahead and store those information inside some data, resource data type, and then we would instantiate them on demand using a global signal. However, we'll show just a different method here where we'll simply reparent the nodes instead of destroying and recreating them on demand. And this is going to be okay for those barrel containers because it's okay if they exist throughout the lifetime of the game. So first, we'll need a place to store those containers on the stage. So let's hop back into the main stage scene here and we'll create a new node 2D. Let's go ahead and call these containers. Okay, so now if we go back to the instance stage 1, we can go ahead and hop over into the containers and we can add a couple of these. So Control-Shift-A and we'll add a few barrels. Let's take one and bring it down towards the beginning of the level. And let's make this contain some food. And then let's duplicate it and have the second one contains a gun. And we'll just go ahead and bring it towards the middle of the first checkpoint. Okay, so with that done, we'll now need a new signal that will allow us to reparent the nodes. So let's hop over into the script and we'll go into our entity manager And here we'll create a new signal. We'll call this orphan actor. Basically, this means that any node who emits that signal will be reparented to the actor's container. Okay, so we'll need to listen to this. So let's hop over into the actor's container script. And back in the onReady function, we'll go ahead and listen to it. We'll create a function called onOrphanActor. Let's bring it all the way to the bottom, and here we'll have a node2d as argument. And the logic here will simply be to reparent that node to itself. Okay, so now we need to emit the signal when the stage is ready. So let's hop back into the stage scene. We'll go ahead and create a script for the stage. And this is perfect. Let's just remove all of this, and we'll give this a class name. And here we'll need a reference to our containers folder. And then when the node is ready, we'll go ahead and loop over all of the children. And we'll go ahead and emit the signal so that they can be reparented to the actor's container. So if we go ahead and start the game now, we should see our barrels properly set. Oh, and that's not the case. So let's look at our remote here, and we can see that the barrels are not placed under the actor's container. So something is wrong with our stage. Let's go ahead and stop. And my guess is because we added the script after it had been instantiated in the world. Yeah. So here you can see that this instance of the stage doesn't contain the script because we had added it before we added the script to the stage. So we'll just need to go ahead and remove it. And then let's go ahead and add it again. Control-Shift-A, stage 1. Now you can see that the script is here. This is really something that's a little bit bothering me within Godot, but let's try this again to see if it works. And still not. Okay, so this is going to be an interesting debugging exercise. So we can first see in the remote here and make sure that the barrels haven't been reparented and they're still part of the world here. Something is wrong in terms of emitting and receiving the signals. And my guess is that there is a little bit of a race condition here, but let's go ahead and prove this. So let's create some print statements here. This is when we emit the signal, and let's hop over into the actors container. And let's go ahead and make sure that we receive the signal. So if we test this again, we'll see that we only emit the signal, but they're never received. So the reason for this is because we connect to the signals in the ready function here. And in the stage, we emit the signals in the ready function. So if this ready function is called before the signals are connected, then they won't be received. And so there's a race condition between the ready of the stage and the ready of the actors container. Now there's a different method that we haven't talked about just for simplicity's sake called init. And init is meant to contain all of the content that is meant to initialize the node, and it is called before the ready function. So typically this is where we would actually do all of the connection to the signals, whereas in the ready function is where we would do all the manipulations of the node. So we won't be going over all of this within our code, but right now what we can do is just change that in our actors container and make sure that we do this as part of the init method. Okay, let's just try this out, make sure that this is now working properly. And we now emit and receive the signal because the receivers are all set up beforehand. So we can now see that we are going in the right Y order. Okay, let's remove our print statements. And then let's go ahead and destroy those barrels just to make sure that they contain the right things. So the first one contains some food, and the next one contains a gun. Alright, so next we're going to be doing just a little bit of housekeeping. If you hop over into the character script, you will see that we currently have a lot of logic within the process method that's not part of any function. And so this just makes it a little bit more complicated to understand what the process method does. We're actually doing 3 additional things here. We're setting the visibility of the weapon. We're also setting the vertical position of the sprites depending on the height of the characters. And then also we're setting up the collisions. So let's go ahead and create 3 methods, and we'll just cut and paste this code inside those methods. First one is going to be called set sprite visibility. And we'll just cut and paste. We'll just go ahead and write it here. Oops. There you go. And then the next one will be called set sprite height position. Let's go ahead and cut and paste these 3 lines. And lastly, we'll just call this setup collisions. Let's go ahead and cut and paste those 4 lines. Alright, so the code does exactly the same thing, but it's just a little bit cleaner. So next, what we'll want to do is we'll want to work on an additional spawn location for our enemies. So right now, we currently support enemies spawning from the left-hand side, the right-hand side, and the bottom of a checkpoint. But another common spawn location inside beatemups is for enemies to just drop on top of the player, falling from the sky, and just dropping next to the player and engaging with the player. So let's go ahead and move one of our enemies to that location and see what happens. So hop over into the stage. Let's take the first enemy here, and we'll go ahead and press Alt on the keyboard and drag the enemy above where the checkpoint is. Then go ahead and press F5 and move over to the checkpoint. Alright, and you can see the enemy here is just walking straight over the wall, just breaking the illusion that there's an actual wall there. So in order for the enemy to drop onto the checkpoint, there's a couple of things that we're going to be needing. First of all, right now, the enemies cannot jump. If you look at the character script, the handle airtime currently supports 3 different states for manipulating the height. The jump kick, which are currently being used by the player, and then the falling state, which is used by all sorts of characters. But we actually don't want the enemies to fall from the ground and land on the ground, be grounded for some time and come back up. We actually want them to just drop on the ground and just be ready to engage right away. So we're going to introduce a new state called drop, where the enemies will initiate as part of this state, and then they'll be able to engage right away. So let's hop over back into the top and create a new state. We'll use the same animation as the idle animation, which means that when the enemies are dropping, they'll just be using the idle animation. And we'll go ahead and hop over into the handle airtime and make sure that we have support for this new state. Okay, so now we just need to initialize the enemies with that state and give them an initial height, and they'll be dropping onto the scene. So if you hop back over into the 2D view, let's talk a little bit about how this is going to work. So right now the enemy here is located at the top. The transform, the feet of the enemies are located here. This is actually not what we want. This is great when you design the level. It makes it easy to see where the enemies are going to be located. But when we delete all of the objects, when we initialize the stage, we'll want to actually initialize it with the right transform and height. So what we'll actually want to do is we'll be checking if an enemy is positioned above the level, and for that we'll just be looking at the transform location of the enemy, and if the transform is the Y transform is negative, you can see that the enemy is above the level. So when we'll be destroying the enemy and recording the data as part of the enemy data, what we'll be recording is for the enemy to actually be located down here, but for the height of the enemy to be somewhere around 40 or 50 pixels. And that way, when they get spawned back in through the actor's container, they actually will see the shadow here because of their transform, and then they'll have an initial height and they'll just drop onto the stage. So let's go ahead and do this. We'll need to record 2 new information as part of the enemy data. When we destroy the enemies initially, when the stage gets initialized, we want to make sure that the state is drop, and we'll also want to make sure that the height is a certain height. We'll probably give it a height of about 50 pixels to let the enemies fall onto the ground. So let's hop over into the script, and we'll start by including this as part of the enemy data. So here, let's check if the position of the enemy is above the level. And if that's the case, we'll go ahead and let's give it a const of 50 pixels for now. Let's see what this looks like. So const drop height 50, and we'll go ahead and use this here. And then we'll change the position so that it's actually 50 pixels down from where it was set up inside the level. Basically here we're setting the feet, so the position of the character, and then we're also setting the height. Okay, we'll need to set the height and the state as part of the exported properties. And here the state will be character.state.drop. Otherwise, the state will be character.state.idle. Okay, so now that this is done, we are recording the right information as part of the enemy data. We now need to be able to use it when we spawn the enemy. So let's hop over into the actors container. And here we want to make sure we pass in the information. So enemy.height equals enemy data.height. We'll also set the state enemy data.state. Okay, so let's go ahead and try this out. All right, and you saw that the character properly dropped from the top. However, there is a single frame initially where the enemy was on the ground and then just teleported upwards to fall down. The reason for this is because if you look at the character script right now, we only set the sprite's height position as part of the process method, and the character may have already rendered before we start processing its logic. So the only thing we'll need to do is make sure that we also call this method as part of the ready variable, so that when the node enters the scene tree, we set the right height position. So let's go ahead and try this again. There we go. And now the enemy properly drops and start engaging with the player right away. Okay, so we have now another good spawn location, and our game is starting to shape up quite a bit. We're going to be introducing one final spawn location, which I think is really cool, and hopefully you'll find it awesome as well. So we're going to be building one final way to spawn the enemies, and this is through having doors in the background, which will open and have enemies behind it, which will just start engaging with the player. And let me just show you really quickly how this will look like. So if you look at your arts folder, you'll see that there's two sprites for the states of the garage door, one of them being the open state. And we'll go ahead and drag this into the scene right now just to see what it looks like. And then we'll go ahead and drag the closed state as well. Both of these are just two sprites, and the way that we will make this work is we'll simply have the position of the closed door translate upwards in order to open the door, revealing enemies in the background. Now, things will have to be ordered in a specific way for things to work properly. If you recall, right now you can see that the enemies and the objects aren't properly sorted, and in order for the enemies to be hidden behind the door, we'll need the enemies to be both part of the actors container and this closed door to also be part of the actors container. It'll just be located, the white position will just be in front of the enemy so that you can hide them. Another thing we'll be doing is the enemies will be waiting here until the door opens up, and then they will start engaging with the player. So we'll be introducing a new state where enemies will be waiting. And if the door is already open and we want to spawn some enemies, then we'll just have them appear. We'll just have their alpha channel go from 0 to 1, and then they will start engaging with the player. So we'll be introducing a couple of new things, a couple of new states, and then a new scene to start doing this. It's also going to introduce something quite interesting, because right now we delete all of our enemies and we just spawn them back using data that we record in the enemy data resource. We're going to be encountering a problem here because we will want to tie multiple objects together. Typically here, we'll want enemies to be bound to a door to which they belong, and we'll need to record this information somehow. So this is going to be a little bit tricky, but we'll go over this one step at a time. So first thing first, we're going to delete those two sprites, and we're going to start by just creating this new state where enemies will be waiting behind the door. Now, you should be very familiar with how to do this now. Hop over into the script, go into the character scene, and hop over back to the top. And we'll go ahead and reuse the same idle animation that we've been using for a lot of those default states. Okay, so now let's go ahead and create a new scene, and we'll make this a 2D scene. So hop over into the 2D view. Let's call this door, and we'll go ahead and add a sprite 2D. And we're just going to add the closed texture to that sprite. And the reason for that is we'll want the open texture to be part of the background, whereas this object will want to be part of the actors container. So as usual, with everything that needs to be Y sorted in the actors container, we want to make sure that the root of the object is located at the origin 0, 0. So let's start by removing the offset, and then in the proper offset, we'll set -24, -32. Let's go ahead and save this into scenes, and let's go into props, and let's call this door. Let's call this door sprites. Okay, and with all that ready, we can go ahead and create a script for our door. Let's keep the same name. We'll remove all of this, and we'll give this a class name. So there's a couple of things that we'll want to do. First of all, we'll want to know how high we need the door to open up. So when we bring this into the scene, and we're going to bring this upwards with the Y position here, we need to know how far up this needs to go. Now, we could hard code that this needs to go to -32. This will have the background here. But ideally, we don't need to hard code anything. We can actually guess the height of the sprite using Godot's code directly. So let's go ahead and set this back to 0. And into the script, we'll go ahead and have a variable to figure out how high the sprite is. We'll set this to 0 initially, and then in the code, we'll go ahead and initialize it. So in the ready function, we'll just set the door height to the sprite.texture.getHeight. Okay, and we need a reference to the sprite here, so let's go ahead and have an onReady variable. There we go. Now, with every object that needs to have different states, as usual, we'll introduce a new enum to store that state, and then depending on the state where it's at, we'll have different pieces of logic. So again, this is going to behave very similarly to everything else that we've been building, the basic enemies, the barrels, and so forth. Let's go ahead and create an enum for state. There's going to be 3 possibilities for the state. The door's either going to be closed, or it's going to be opening, or it's going to be opened. And we'll get started with the closed state. So we'll want to store a variable of the state internally to store this. Finally, because the door needs to open, we'll need to have a property to figure out the duration of how long it needs to take. So let's go ahead and create another, create an exported variable. We'll call this duration open. We'll make this a float, and then in the object here, we'll set this to 1 second to start with. Okay, and finally, we will need to open the door depending on the state. So we will have a function called open, which won't return anything. And the entire purpose of this is to open the door. So let's first check what the state is. And we want to make sure that we are currently in the closed state. If that's the case, then we'll want to open the door. So we'll set the state to state.opening. And then we'll want to keep track of the time. Again, every time we have a duration, we want to keep track of the time to know how far up or the progress of the movement needs to be. So here in our variables, let's go ahead and create a new variable. Let's call this var time start opening. We'll set this to the current time to start with, but we'll actually set it here when we actually are opening the door. We'll reset it to the current time frame. All right, and now the only thing we need to do is have a process method where we'll check the state, and depending on the state, we will be having different types of logic. So func process delta. We're not going to be using delta here, so let's go ahead and prefix this with an underscore right away, get rid of the warning. And so here we'll want to check the state. So if we are currently opening the door, and the first thing we'll want to do is check if we've spent enough time opening the door. So if the current time minus the time when we started opening, if that's bigger than the duration, we know that we have completed opening the door. And so here we'll want to set the state to state.open, which means we'll never come back here because this if condition is for opening. And then next we'll go ahead and let's set the sprite position to where it should be, just in case it hasn't made its way all the way up there yet. So we want to locate the door position to vector2.up times the door height. And finally, we'll want to emit a signal to let everyone else know that the door is finally open, and this will allow enemies that are bound to this door to start engaging. So let's go ahead and create a signal here, and we'll just call this signal open. And we'll emit it right after this line here. So open.emit. Okay, and if we haven't spent enough time, we should still be opening the door. And this, the only thing we'll need to do is to know, well, how far up does this sprite's position needs to go. And for that, once again, because we have a final duration and we have a timestamp, we just need to check the progress between the duration and the current timestamp. So the progress is current time frame minus the time when we started divided by the duration. Okay, and so this is going to be a variable between 0 and 1. In percentage of the progress of how far up it needs to go. And because we have that, we can simply use the lerp function. And this door is going to go from vector2.0, and the final position is going to be vector2.up times door height. And how far along it has gone is progress. Okay, so we can actually try this right away. So let's hop over into the world scene. And let's bring in our door. So let's hop over into the actors container, Control-Shift-A, bring a door, and let's bring it here. Actually, let's bring it here so we can see it. What we'll do is inside the door script, we'll make sure that as soon as it's ready, we'll go ahead and open the door. And now when we start the game, we should see the door take a second to open up. Let's go ahead and try this out. There we go. And you can see the door open up. Now it looks kind of weird because we don't have any background here, but we're going to be adding this as part of our stage when we add the doors inside the stage directly. Okay, so we can go ahead and remove this. And also let's make sure that we remove what we just added here. We don't want the door to open right away. We'll want to open the door when enemies need to come out. So now that we know that we have a properly working door, let's go ahead and add it to the stage. So similarly to what we did for the containers, we're going to need to reparent the door so that it can be part of actors container. So let's go back into the main stage scene and let's add a new folder for the doors, Control-A, add in a 2D. Let's rename these doors, Control-S to save, hop over into the instance, stage 1, and then back in doors here, Control-Shift-A, and let's add our new door object. Let's go ahead and drag this into where, towards the left-hand side of the first checkpoint. And actually, before doing this, let's bring this upwards a little bit. Let's bring the background. So back into the backgrounds, Control-A, let's add a sprite 2D. And here the garage door open texture, we'll just drag this into the texture property. Let's bring this towards where we need it to be. And then let's zoom in a bit, make sure that it's properly aligned. And then let's take the door that we just created and properly align it here. There we go. Okay, so now that we have a properly working door, we'll want to have some enemies behind the door, patiently waiting for the door to open, and then they'll start engaging with the player. So we will need a couple of things. First, let's create 2 new enemies. We'll just duplicate those 2 basic enemies here. And let's bring them right behind the door. Let's make sure that the Y position is above the closed door so that they can appear behind. And let me just drag them a little bit more towards the center so that they can fully be hidden. Okay, so we need a reference to those enemies and we need to bind them to the door. So let's hop over into the door script and we will add an array of enemies. So the type will be basic enemy. And now what we can do back into the stage here, if we look at the door that we just created, is we can increase this array and have two enemies that we can just assign by dragging and dropping them. So those two enemies that we just created, actually let's bring them upwards so that way they're the first ones to engage, and then let's go ahead and drag them into our door property here. The first one will be the one on the left, the second one will be the one on the right. When we delete those objects, we want to keep the binding, we want to keep the tie of those objects to this door. Now, if we were to hop over into the enemy data, and if we wanted to say, let's specify a door here, you'll see that Godot will complain because the resource type does not support other types of nodes. It only supports basic data types. So these are enums, which are integers, vector2s, which is just a set of two numbers, but it cannot support those type of relationship. So here we're a little bit stuck. And there's multiple ways to do this, but one way that I find works well is rather than keep a reference to the actual door object, we're going to keep track of which door index an enemy belongs to. And if we have multiple doors, so we'll have this being the index 0, another door might be index 1, and so forth. So we'll just only need to keep track of the number of the door, and if the number is -1, then we'll just say that the enemies aren't attached to any doors. But if the index is higher than 1, then whenever we create those objects through the actors container, we will just remap them to the proper door. So let's go ahead and do that. Back into the script here, rather than keeping a reference to the door, we'll keep a reference to the door index. So here we'll just call this door index, and we'll make this an integer. And we'll need to have means to pass this data whenever we create this enemy data. So let's go ahead and add it to our constructor here, and we'll have assign door index, which will be an integer, and by default we'll set this to -1, so it's not attached to any door. Here we want to set the door index to assign door index. Okay, so now the only thing we'll need to do is when we create those enemies data, we want to make sure that the assigned door index passed as part of the constructor is properly set. And if you remember, we do this as part of the checkpoint here. This is where we destroy the enemies, and this is where we record the information as part of the enemy data. So here basically we'll want to have a track of the enemies.door index. Now enemy currently does not contain any information about door index, so we can go ahead and add that. Hop over into basic enemy and we'll create a new variable here called assign door index, which will be set to -1 by default. Okay, and now as part of the checkpoint, we'll go ahead and pass this. All right, so now the next thing we'll need to do is actually properly assign this variable. And the way that we've set things up is the enemies currently don't know about the doors that they're assigned to, but the doors know about the enemies. So we'll need to do two things. First, similarly to what we did with the barrels, we'll need to reparent the doors. And when we do that, we'll also check which index the doors are at. And if they contain any enemies, we'll just make sure to set that information properly. So let's hop back into the script, hop over into the stage script. Here we'll copy and paste those two lines. We'll do the same thing for the doors. We'll need a reference as well. And let's go ahead and reparent them. So for each door, let's go ahead and reparent it to actors container. But before we reparent it, what we'll want to do is check if the doors have enemies assigned to them. And if that's the case, then we'll go ahead and set the proper assigned door index. So for this, we'll need to keep track of the index of the door. So rather than doing a for loop like this, we're going to use a for I in range. And this means that here we have access to the actual index. doors.getChild I. So here, within this loop here, I represents the index of the door. This is going to go through every single child of the doors container here and assign I to the proper index. So here the only thing we'll need to do is check if the door has an enemy assigned to it. And if they do, then we'll, here actually let's just do this. That will be nicely typed. And here we'll go ahead and set the assigned door index to I. Okay, so that means that when the stage gets started, we reparent the doors, but while we do this, we also set to the right index of the door to any enemy that may be assigned to it. So now we have all the information necessary for the actors containers to properly assign the doors to the enemies whenever they're created. So let's hop over into the actors container, and here when we're spawning the enemy, what we can do now is check if the enemy has, if the enemy data has a door index attached to it. And if this is greater than -1, then we'll actually want to send that information to the enemy and tell it to wait for the door to open or try to open the door. So currently we don't have any logic for the enemy to handle the door. Let's go ahead and add that really quickly. So hop over into the basic enemy and we'll create a new method. Let's go ahead and let's go right under the handle prep shoot. And here we'll have a function called assign door. We'll pass in an actual door object, not a door index. First, we'll make sure that the door is closed. If that's the case, then we'll go ahead and wait. But we'll also tell the door to open. And finally, we'll want to make sure we connect to the signal. So door.open.connect. And what happens when the door is open? Well, we'll just want the enemies to swap from the waiting state to the idle state. And we currently have a callback called onActionComplete that we've been using quite a bit within our animation. And this will transition back into the idle state. Okay, so now we have a method called assignDoor, which takes a door and allows the enemies to properly have their logic. Let's hop back into the actors container. And here we'll want to call this exact method. So enemy.assignDoor. And the problem here is that we just have the door index. We know which number of the door it is. We just don't have access to the door object itself. So actors container needs to know about the doors. There's multiple ways to do this, but one quick way that we can do is currently doors are being reparented to actors container every single time. So here, whenever we hop into this method, we can just check, hey, who is being reparented? And if this is a door, let me just keep track of it so that whenever we assign a door to an enemy, we have that information in memory of this object. So for this, let's just keep track of the doors, create a new variable. Let's call it doors. This is just going to be an array of door. And by default, it will be an empty array. And then when we reparent the object, let's just check if the object is a door. If that's the case, we'll just go ahead and append it to our array. So now we have access to all of the doors, and the only thing we'll need to do here is pass in the door index. Okay, so with that done, let me just recap the logic real quick. Whenever we start the stage, we're going to be doing two things. We're going to reparent the doors, and we're going to assign the door index to the enemies. So that way, when the enemies get destroyed as part of the checkpoint, we pass in that information as part of the enemy data, which we record. And whenever we recreate the enemies as part of the actors container, we can just check whether there is an actual door information and reassign it properly. So the last remaining thing is we have a bunch of logic and flows that are going on. We want to make sure that those are properly orchestrated. Right now, if you look at checkpoints, you'll see that in the ready function is where we do all of the destruction and recreation of the enemy data, but all of this might not be ready by that time. So we actually want the stage to control the flow of all of this. So for that, let's go ahead and bring this into a new function We'll call this create enemy data, paste the code, and then we'll want the stage to actually call this whenever it's ready to go. So hop over into the stage script, and here we'll need a reference to our various checkpoints. And after we've done all of the initialization, we'll loop over our checkpoints. And we'll create the enemy data. All right, so with all of that done, we can go ahead and press F5 to try this out. And I expect that when we cross and enter the first stage, we should see the two enemies. So those are not the enemies I'm expecting to see. I'm expecting to see people coming out of the garage door here. So I'm wondering if something isn't set up properly. Let's hop over into the stage street here. Look at our enemies. Oh, they're currently being part of checkpoint 2. You might have caught this earlier. We actually want these to be part of checkpoint 1 so that they get triggered whenever we cross this line here, and they'll be the first enemies to come out. Let's try this again. F5. Let's cross this. Okay, and this almost worked. You saw that one enemy was waiting while the enemy wasn't, the other one wasn't waiting. And so I'm thinking that there's probably something wrong with our script within our basic enemy. So when we assign the door, here we check if the door is closed, otherwise we open it. So this is going to work for the first one, but because we open it, the second one will not have the state closed, but the state here will be opening. So let's just double check that the state is not opened. And that should actually work. There we go. Both are waiting, and now both are engaging. All right, and there we go. So that was a ton of work needed to get this done. As you can see, most of the complexity was coming from the fact that we keep reparenting and setting up the scene in a specific place, but then we have to move objects around so they're properly Y-sorted. But anyways, one good thing that we are building here is if you look at the enemy data, you'll see that those classes are actually quite simple. And you could imagine that you wouldn't even need Godot to set up the stages. And this is typically what people will do in a bigger game studio. They'll have game designers who will have map editors where they can place things. And then the map editors will just record the information here using the same information that can then be reloaded as part of the enemy data into the game. So that's actually something that's more common than you'd think. But it's important to kind of see those challenges. Sometimes you have relationships that need to be mapped into simple data types like the index of the door. All right, well, this is going to be it for this episode. We went well over the 30-minute mark, but I did want to illustrate a more complex type of setup for the enemies so that you can see the process of taking complex relationships and translating them into simple data types. So the game is getting somewhat a bit complex, so if you have any questions regarding any of the logic or code that we wrote, please hop over into the comment section and I'll do my best to respond quickly. So actually, before you start on to the next episode, I have a little challenge for you. So right now, if you assign enemies to a door that's already opened, they will instantly pop in the background out of nowhere. Let me just show you this real quick. So if we hop over into the stage and we'll create a third enemy, let's move it towards the center and let's make sure that it's assigned as part of the door enemy. Let's bring this here and try this out. So the first two enemies are waiting. This is good. We'll go ahead and kill them and just watch the background here. And you'll see that the third enemy just popped out of nowhere. And that could be okay, but that also might look a little bit odd in my opinion. So what I'd like for you to try to do for the next challenge is to try to find a way for the enemies to slowly appear in the background and then only engage once they are completely appeared with the player. And try to do this and we'll correct it in the next episode, but I think it'll be a good way for you to practice whatever we've learned so far. Anyways, thanks again for watching this tutorial series. I think their game is really starting to look great. And if you like this type of content, please consider supporting the channel if you haven't done so already. Once again, if I reach 1,000 subscribers, I will have you choose the nature of the next tutorial series. So time to take a quick break, and I'll see you in the next episode. Cheers!